Hi everyone, and in this video we will we'll go through linear regression with simple explanation with lot of examples and what does this mean in machine learning. Okay, so let's start. So this linear regression, as you can see in this graph, that it models the relationship between the dependent variable, that is y, it is plotted on y-axis, and the independent variable which is plotted on the x-axis. Okay, and it is just two variables in simple linear regression, whereas if you want many variables, then you will require multiple linear regression which can handle more than one features. Okay, more than two features actually. Now I have taken this example to show you how it is being plotted in your Jupyter notebook. So what you do is you take two objects or variables a and b. In that I will store these values like this will be equal to np dot arrange 10 to 20. Now this np dot arrange is a function in numpy which will return me evenly spaced values in the given interval. So this is returning me 10, then 12, 14, 16, 18 evenly spaced value, right? And the given interval is with a difference of 2. Similarly here in B, I have it between 30 to 40. Again, it has arranged itself by itself automatically with a difference of 2. And it has given me a scatter plot. And this scatter plot, as you can see, is perfect positive linear relation. And this is linear regression, as you can see. So this is positive because it is moving. Since the value of x is increasing, the value of y also seems to increase. So this is a positive relation and you can see the line upwards. Suppose this line is drawn downwards, that means it is negative relation. With the increase in value of x, the value of y would decrease. Okay, but this positive relation, both will move in the same direction. Okay, now let's move ahead. In regression, we often come across this term of line of best fit, and you can see this line of best fit. Now suppose that now in this example there were just few values and you simply got a simple regression. Now suppose if you've got many values and your plot looks like this, then what will happen? Now this is an example I've taken from total bills and tip data set, which we've done it as a data analysis to understand the Simon library and the plots of it. Now what happens here? Now suppose you've got various data, lots of data, and it is being plotted like this. Now you have to determine a line across all these points which can help me understand the variance, the spread of the data, and my error is reduced and it is fitted in this model. So what happens is this line tells me the best fit. Okay, and I call this the line of best fit in linear regression. This determines the relationship between the variables. Okay, this is total bill and this is tip. So this tells me the relationship between bill and a tip. If suppose the bill is huge, is the tip also huge? If I'm paying like around $40, then the tip also varies from like $4 to $6. Okay, so now this simply works with the simple concept of equation of straight line, which is given by y is equals to mx plus b. Okay, here m is slope and b is the intercept. Okay, and how do you calculate this thing? The value of intercept and the slope is through least square, and there are various other methods which can be used to calculate this slope and intercept. So this intercept, it starts from here, and this is the slope of the line. Okay, so this regression line, this determines the best fit. Now, what if, why this line? Now the next question is, why only this line? Why can't my line be this red one? Why can't my line be this blue one? This black one? Why this blue line is the best fit? Now, to determine this, that this line is the best fit, this is the fitness or the best fitted line, we have something called coefficient of determination, and this is also called r square. So when you have r square, it will allow us to determine that how certain we can be in making predictions with this line of best fit. Okay, so this R square, it now to term it, to give you a definition of it, this measures the proportion of variability in the dependent variable, which is explained with this line regression model through independent variable. So how my independent variable is able to explain the variation in the dependent variable. Okay, that is the coefficient of determination. How well is it explaining? Is it capturing all the variations or not? Okay, so how do you, this R square, what is this R square now? How is it being calculated? So this R square has been calculated by squaring the value of R. Now some new term is coming, which is correlation coefficient, and the formula is given by n sigma xy minus sigma x sigma y divided by under square of n sigma x square minus sigma x the whole square into n sigma y square minus sigma y the whole square. Now this is a simple formula which is being taken care by the model. You don't have to like go through the calculations of it, but just remember this, that this R is the correlation coefficient, and when you square this you will get the coefficient of determination, which will tell me the fitness of my line. Now this R square value is between 0 and 1, and if it is close to 1, this means the model is explaining most of the variation, and if it is 0 or close to 0, that means it is not explaining the variation. Now suppose if it is coming like R square value is coming to 0.85, that means that my model is explaining the variation well. It is capturing 85% of the variation. Okay, so now let's come to this R, which is correlation coefficient. Now this measures the strength and the direction of a relationship between the two variables, how strongly they are related and what direction they are moving. Either they are positively moving in the same direction or negative moving in opposite directions. Okay, so let's understand with the help of an example again. The R value, it lies between -1 to 1. You understand this thing? This is positive relation. Okay, but this is not perfect linear relation, so I cannot say this is +1, but I can say that this is strongly related. Okay, even this figure, this is a scatter plot which is plotting the relationship, okay, which determines the relationship between two variables. All right, suppose your total tip and total bill, these are two variables, and how total bill is affecting the tip, right? If it is increased, is the tip increasing? Yes, we see that it is increasing, right? And this purple and this green marks, as you can see, is these are different variables which will, you go through that example and you'll understand it better. But just understand that this, take this purple dots only. Okay, now this -1 is perfect negative linear relation, that means they're moving in opposite direction. +1 is perfect positive linear relation. When you've got 0, that means there's no linear relationship among the two variables. If my value is like suppose close to +1, suppose like I give you an example here. If it is close to +1, that means 0.94, that means it is very strongly correlated. And this example is of iris data set, which is a classic example of machine learning. And this is the flower which looks like, and it has got 3 classes which we had to determine in a machine learning project, which we have done it also. I'll give you the link in the description box. Please go through it. The data analysis of iris flower, and you can see here that you've got 150 data set here, and you've got 4 columns, right? Attributes. So now we've got these attributes and its relation with the target, and we see that the petal length and petal width, this petal length and petal width are very highly related with the target. It's very strong positive relation. If target, it's 0.94 and 0.95, and when we see with sepal width, it is negatively correlated, and that too weak correlation because it is 0.4. Okay, and sepal length is 0.78. Okay, so we can determine the correlation with the target and whether that is an important attribute or not, whether we should go ahead or drop it. So these decisions can be taken with the correlation. So that is what these values determine, and it lies between -1 to +1. And for r square, this value lies between 0 to 1. Okay. So I hope this is clear what linear regression is. And if you've got any doubt, please post it in the comment box. And that's it for this video. Thank you.